Square roots, cube roots, and others. I don't mean other people, I mean other kinds of roots. Okay? I'll be rude to talk about other people. The square root of 2x plus 1 equals 5. Now, I really honestly don't think you're going to have any problem solving this, but I wanted to walk you through the steps anyway. Why don't I think you're going to have a problem solving this? We've already talked about it a little bit, haven't we? Okay. How do we undo a squared? Excuse me, I just told you the answer. How do we undo the square root? We square it. Okay. If I square both sides, which I have to do, right? I square both sides. What do I end up with on the left-hand side? 2x plus 1. What do I end up with on the right-hand side? 25. And then basically I just have an algebra 1 problem that I have to figure out now, right? Subtract 1 from both sides. 2x equals 24. Divide both sides by 2. X equals 12. Is it right? Could we be sure? Okay, so 12 times 2, 24 plus 1, 25. What's the square root of 25? Does 5 equal 5? Then I'm sure of that answer, right? I'm sure of that answer. Okay. How do I solve this problem? What do I do first? Okay, if I add 6 to both sides, I get 2 square root of x equals 20. And then divide by 2, right? So on the left-hand side, I have square root of x. On the right-hand side, I have 10. How do I undo a square root? Yeah, square it, right? X equals what? 100. Is it right? What's the square root of 100? 10 times 2? 20 minus 6. Does 14 equal 14? Yeah, so I know for a fact that that is correct, don't I? Okay. Now, you've done problems like this for a while. It may not have been square roots. It may have been squareds. It may have been just x's in general, okay? But what I want you to realize is that when we're solving equations with any sort of roots in them, what we're trying to do first is isolate the root. Now, in this first problem, the root was already isolated, wasn't it? And I just had to square both sides and solve it from there. This one, I had to do some steps to get the root isolated. I had to get rid of the 6. I had to get rid of the 2. Why didn't I have to do that with the 1 and the 2 here first? Yeah, they're both under the root, right? I isolate the root. Doesn't matter if there's anything inside there. The root is isolated at this point, and then I can square both sides and solve. Okay. In this particular problem, I had to isolate the root first. Had to get rid of the 6, had to get rid of the 2. Once the root is isolated, then I can square both sides. And what happened to be inside in this problem was just an x. That gave me my answer. Okay. So what happens when it looks a little bit more difficult? Does that automatically mean it is? No, but doesn't mean it is sometimes. Yeah, okay. So let's look here. X plus 5, square root of x plus 5 equals x plus 1. What do I have to do first? What's my goal? Isolate the radical, right? Isolate the root sign. Is the root sign isolated? Yes, so how do I undo that? I square it. I had to square both sides, right? I have to square both sides, right? Yeah. Okay. So on the left-hand side of this equation, I just get x plus 5. What happens on the right-hand side? We talked about this yesterday, didn't we? I can't just say x squared plus 1, can I? I have to square the x plus 1. So I have to distribute, right? So x squared plus 1x plus 1x plus 1. Now I could simplify it over here, but then I'd just have to write it again over here. So is it okay if I write it over here as I simplify it? So x squared plus 2x plus 1. Now what kind of problem has this become? Definitely a quadratic, right? It's definitely a quadratic. So if it's a quadratic, what do I usually need to get it equal to? 0. That's right. Yeah, 0. So if I'm going to get it equal to 0, what do I need to do that? Minus 5 and minus x, right? So 0 equals what? X squared, good, plus 1x minus 4, okay? X squared plus x minus 4. Do we know how to solve quadratics? Oh, we better. We worked on them for a long time, right? Okay. We know 5 ways to solve them. Do you remember what they are? Graphing, square roots, completing the square, factoring, and your favorite one and mine, quadratic formula. Okay. Quadratic formula. So how do you want to try to solve this? Factoring is the easiest way, right? Do you know a number that, or two numbers that multiply to be -4 and add to be +1? Dang it. We don't, do we? Okay, so usually our next step, if we try factoring, it doesn't work. Usually that would be what? Quadratic formula. Okay, so in order to do quadratic formula, I need to know A, B, and C. In this problem, what is A? 1, right? Because that's what's in front of the x squared. You're right. But remember, A is not the x squared. It's the thing in front. Okay, what's B? 1. And what's C? -4. Okay. X equals -b plus or minus the square root of b squared, which is 1, minus 4ac all over 2a. So I'm going to write some work out here. 1 minus, what's 4 times 1 times -4? Yeah, times, right? Times. So -16. So that's going to end up being x equals -1 plus or minus the square root of 17 over 2. So all the stuff we've done so far, did that make this problem harder? No, we already know how to do this, right? Now there's more steps for sure, right? There's definitely more steps, okay? I wish we could have factored. If we could have factored, that would have made things a lot easier. But instead we get an answer like this. I can't simplify this any further, can I? Okay. So what was really important about these two answers is that I did what? Yeah, I plugged them back in, right, to check them to make sure they were right. Is it that important, really? Yes, we need to do that. Do you want to plug in -1 plus the square root of 17 over 2? Yeah, neither do I. That's a mess. Okay, so what I want to do instead is I want to take my calculator out. Yeah, calculator. I'm going to take my calculator out. And in my calculator, I want to put -1 plus the square root of 17 over 2. I can't do them at the same time, right? -1 plus the square root of 17 over 2. -1 plus the square root of 17 over 2 is 1.56 155. Did you get that? Yes? Okay. Then I also need to do, whoa, not that. -1 minus the square root of 17 over 2. So -2.56155. So those are the two answers that I got that are going to be easier to plug back in. You okay with that? Is this a wrong answer? No, absolutely not, right? That's a perfectly acceptable answer, but I want to be able to plug them in to make sure they're right, so I went to the decimal to make it a little easier on myself, okay? All right, so since these numbers are kind of, well, I don't want to say ugly because that seems judgmental, but I want to say the square root of x, you guys mind if we do the positive one first? 1.56155 plus 5. Okay, so when I plugged in 1.56155 and I added 5 to it and took the square root of it, I got 2.56155. Did you guys get that? So if I add 1.56155 to 1, what am I going to get? 2.16155. So does 2.56155 equal 2.16555? Or only 2 fives? I meant. So does this one work? Yes. Okay. Now I need to plug the other one in. Square root of -2.56155 plus 5. I got 1.56155. So when I plug this in on the left-hand side, I get 1.56155. And I'm trying to figure out if that's the same as x plus 1. So -2.16, no, sorry. Oh, geez Louise. 56155 plus 1. Are those two equal? So is this an answer? It is not. Do you see now why it's important that we plug in our answers? Yeah. Okay. Any questions? The square root of x plus 5 plus 8 equals 2. Oh, on this example, I'm going to try to trick you. You ready? Okay, what do I do first? So I'm trying to isolate the root, right? I'm trying to isolate the radical. So what do I do first? The square root of x plus 5 equals -6. What do you want to do? You want to square both sides? Okay. If I square both sides, what do I get on the left-hand side? X plus 5. If I square the right-hand side, what do I get? 36. Now what do you want to do? -5 from both sides. X equals 31. Should we check it? 31 plus 5. What's the square root of 36? 6 plus 8 equals 2. Uh-oh. Did we do any of our steps wrong? We did not. Okay. I need you to come back to this step right here, though. This is where we got tricked. Guys, when are we going to take the square root of a number and get an answer that's negative? Never. From this step right here, we could have said no solution because it's a square root equaling a negative number. Does that make sense? Okay. Now, we happened to do all this stuff, and when we plugged it back in, we knew it was wrong. So we got to try to figure out where we messed up. Go back and look. Did we ever get a square root of a negative number? If we did, it's no solution. It's not that we messed up anywhere. It's that we had a square root equaling a negative number. Okay. Can I show you another one? The cube root of x plus 5 equals 7. Now, I think you know how to do this without me even telling you, because what we talked about the last couple days. How do we undo a cube root? Yeah, exactly. How do we undo a square root? We square it. How do we undo a cube root? Cube, cube, right? What's left on the left-hand side? X plus 5. What's left on the right-hand side? 343, right? Oh, you knew that off the top of your head? I'm sorry. Sorry. Oh, use the calculator. Okay. I'm not sorry. It's okay. Even if you did know it off the top of your head, that's awesome. But if not, it's also awesome because we know how to use our calculator, right? To get the information we need. What's left to do? Good. So what does x equal? 338. Okay, so what's 338 plus 5? 343. And what's the cube root of 343? 7, right? Does 7 equal 7? Yeah. Can I try to trick you again? Can I try to trick you again? Okay. What do you think? Except this time it's not. I'm glad you have that in your head, right? I'm glad you have that in your head. But what happens if I cube both sides here? What do I have left on the left-hand side? X plus 5. What do I get when I cube a negative 7? Negative 343, right? Negative 7 times negative 7 is positive 49. And positive 49 times negative 7 is negative 343, right? If I subtract 5 from both sides, I get x equals negative 348. What is negative 348 plus 5? Negative 343. What is, also I'm going to make sure you know how to do this in your calculator just in case, okay? The cube root of negative 343. Oh, why can you not even see that? That's so weird. Is that better? Okay. So I'm going to back up to make sure you saw what I did. I used control and then the up arrow. Instead of control x squared, I used the control up arrow to give me this kind of root so I could put a cube root out there. That does have an answer. Okay. So how are we going to be able to tell the difference? Whether it's no solution, whoops, whether it's no solution or whether we can get an answer. So squares can't give you a negative answer. Cubes can. Are we only doing squares and cubes? No, we're doing others as well, so we need to make a little bit more general rule. That's a really good observation that squares cannot equal negative numbers, but cubes can. What about fourth roots? We could think about this with our head, right? So like 16. Isn't 16 2 times 2 times 2 times 2? So 2 times 2 times 2 times 2. Can I do negative 2 times negative 2 times negative 2 times negative 2? But can I do a fourth root of negative 16? What? Oh yeah, go for it. Go. Even roots can't get a negative as our answer, but odd roots can. Does that make sense? Okay, so even roots, anytime it's an even root, I need to be clear that you know what I mean by even root. Square root, fourth root, sixth root, eighth root, 10th root, 12th root. If it's an even root, I cannot have it equal to a negative number. That will be no solution. But if I have an odd root, third root, fifth root, seventh root, ninth root, and so on, that can equal a negative number. We good? All right, let's do this one, because this one is super hard. You can tell I was kidding, right? Why was I kidding when I said it was super hard? I square both sides, right? At least this radical's isolated. Well, in this case, both of them are, right? Both of them are isolated, so what do I have left on the left-hand side? And what do I have on the right-hand side? Oh my gosh, that's the opposite of hard, right? Because then I subtract x from both sides and I add 1 to both sides. What does x equal? 5. Is it right? What's 5 plus 4? 9. What is 2 times 5? 10 minus 1? 9. Now, in this particular example, what I got as my answer is the square root of 9 equals the square root of 9, right? Now, like I said, in this particular example, I happen to know the square root of 9. I happen to know it's 3, right? 3 does equal 3. But what if this number was like 17? Or like, we'll just make it 19, because I don't know the square root of 19 either. Do I have to know what the square root of 19 is? Or is it good enough to know that the square root of 19 equals the square root of 19? Yeah, for sure. I don't have to take this down to a decimal just to make sure they equal each other, right? Because I know that the square root of 19 would equal the square root of 19. Okay? Now, I've got to throw a little wrench in this, but it's just a really tiny one. Okay? If you'll remember, the very first problem that we did today looked like this. 2x plus 1, square root of 2x plus 1 equals 5. Okay? And we did all our work, and we got x equals 12 as our answer. Right? Guys, what if I gave you a problem that looked like this? 2x plus 1 to the 1/2 power equals 5. Would you panic right away? Or would you think with your brain for just a second? Hopefully you would think with your brain, okay? I know some of you would panic because that's just how you are, and I accept you for that, okay? But hopefully some of you would realize if there's a fraction in the exponent, how could I get rid of that fraction? I could multiply by its reciprocal, right? Starting with the denominator, right? That would be a 2. So in this case, it happens to work out like that because the numerator is 1, right? But if I multiplied by its reciprocal, that would make 2 over 2, which would be 1, right? Isn't this squaring? Didn't I just square it? For this exact problem, it's just squaring it, right? But what I'm actually doing is I'm raising both sides to the same power. Okay? What do I end up with on the left-hand side if I do that? And on the right-hand side? And doesn't this look similar to the problem we did in the beginning? And don't I end up with the same answer? Do you remember this foldable that we made? Hopefully you still have it. On the very last page of the foldable, that's called Other Cool Exponent Stuff. That's the technical terms, right? I told you this. I told you we were going to have to end up dealing with fractional exponents, right? And I said the numerator is the power, the denominator is the root. And at the time, it wasn't really that important. We just needed to know that all of our exponent rules worked with fractions as well as they did with like whole numbers, right? But now is when it's super important. Because if I have a numerator and a denominator and the power is the numerator and the root is the denominator, what does it mean for something to be raised to the 1/2 power? This is the power. This is the root. What kind of root is this? Isn't that just a square root? Isn't that exactly the same as this? This is just written with a root. This is written with a rational exponent. Does that make sense? So if I give you a problem like this, 4x plus 1 to the 1/3 power equals 2, could you answer that question for me? What am I asking you to do? I'm asking you to take the cube root of something. Well, how do we undo the cube root? We flip that fraction and raise it to the 3rd power. So this is 4x plus 1, and this is, what's 2 to the 3rd power? 2 times 2 times 2. 8. And then if I subtract 1 from both sides, excuse me, I get 4x equals 7, and divide both sides by 4, I get x equals 7 over 4. When I go to plug it back in, 4 times 7 over 4 is 7. 7 plus 1 is 8. 8 to the 1/3 power. The top is the power, the bottom is the root. So what's 8 to the cube root? What times what times what equals 8? 2. Does 2 equal 2? Yes. And because you know that now, I don't need to do an example of a 4th root or a 5th root or a 6th root or any other root, because you know it's the same rules that apply as before, right? So just in case, 2 to the 4th root of x plus 1 minus 3 equals 9. How do I do that problem? What do I do first? Add 3 to both sides. 2 times the 4th root of x plus 1 equals 12. What do I do next? Because remember, what I'm trying to do is isolate the root. So I need to divide by 2. I got to get rid of the 2, right? So I have the 4th root of x plus 1 equaling 6. How do I go about solving this? How do I undo a 4th root? I fourth it. You could say that if you want. You could also say we raise it to the 4th power. I'm not going to laugh at you out loud if you say fourth it, okay? Left-hand side, I have x plus 1. Right-hand side, I have, do you know 6 to the 4th power? I don't. I had to check. 6 raised to the 4th power. 1296. And to solve for x, I just subtract 1. X equals 1295. Well, is it right? What's 1295 plus 1? 1296. What's the 4th root of 1296? Remember, if you don't know it, you can always go to check. 4th root of 1296. 6. Okay. So 6 times 2? 12. 12 minus 3? Does 9 equal 9? So I know that that's correct. We good? Any questions? Okay. On this worksheet tonight that I'm handing you right now, you are doing 1 through 10, and that is all. Okay. If you want to do extras, you can do 11 through 15, but do not do the back. We're not quite ready for the back yet. Okay. Any questions?